All right, so what if I asked you how many moles of carbon tetrachloride are in a 200 milliliter sample of carbon tetrachloride? You'll notice I'm giving you the volume instead of the mass. And the reason for that is carbon tetrachloride is a liquid. And when dealing with liquids in the lab, it's preferable to just measure their volumes rather than weigh them. Okay? And for pure liquids in particular, it's you can easily convert volume to mass using the density of the liquid, which would be known. It's something you can look up. It might be on the label of the bottle of liquid that you have. So density is mass over volume. Okay? So if you know the volume, how do I solve for the mass? If I know the volume, how would I solve for the mass? I know the density. Mass, no, mass is density. Density is mass over volume. So if I want to solve for mass, okay, I multiply density and volume together. Okay, so that's what we would typically do in the lab. We measure the volume. So let's say we measure 200 mils of carbon tetrachloride. What should I do? I have milliliters of carbon tetrachloride. I have to change that to grams first. And once I know the amount in grams, since it's a pure liquid, so it's a pure substance, if I know the grams, I can just convert it to moles. Okay? So what information do I need to go from grams to moles? I need the molar mass, right? Grams divided by molar mass gives you moles. Milliliters, that's volume, multiplied by density, that gives me grams. So let's see what we can do with this. You're given 200 mils of carbon tetrachloride. Okay, multiplied by the density, which is given here. You can look this up for carbon tetrachloride. It's 1.59 grams per milliliter. So milliliter would be 1 milliliter per milliliter, since that means for 1 milliliter of carbon tetrachloride. So milliliters carbon tetrachloride cancels out. So you've converted it to grams. So what answer do you have at this point? 2 times 1.59. Okay, in regular notation. So 200 mils here. Okay. Oh, sorry, that's not 2.00. That's 200. Okay, that's 200. So 200 times 1.59, that's 318 grams. And at this point, you already know how to work the rest of this problem out. How do you change grams to moles? You need molar mass, right? So you can just say times 1 mole of carbon tetrachloride divided by the molar mass. The mass of 1 mole is 153.8 grams. Okay, so you divide by the molar mass to get moles. And this gives you 318 divided by 153.8, 2.06. So I have 2.07 moles. Grams cancel out, and I have my answer in moles. 3 significant digits. I have 3 significant digits. Oh, this is just 200.0, so that's 4. But my density only has 3, so that's 318. And so my final answer should have only 3 significant digits, 2.07 moles. Okay, let's try another example here. Let's say you have doing an organic synthesis experiment, and it calls for 0.200 moles of ethanol. Now, the formula of ethanol is C2H5OH. And ethanol is a liquid with a density of 0.785 grams per milliliter, and the molar mass is already given to you. You don't have to figure that out, or normally you should be able to. Hold up. Okay, so what volume of ethanol do we need? So what are we looking for here? The volume of the ethanol, right? So mils of ethanol is what we're looking for. Okay, So how do you get, what information do you need to determine males? What relationship do you know? Density is mass over volume, right? So I need to solve for the volume. So somehow I need to know mass and density, right? If I know mass and density, I can get my volume. Okay. Now, do I know my density? Yeah, I do. So somehow I have to figure out my mass from what's given in the problem, right? How do I get my mass? Mass, remember, what was the relationship? Mass equals number of moles times molar mass, right there. So if I want to know mass, I need to know number of moles and the molar mass. So to get my mass, I need to know number of moles and molar mass. And that will give me my mass. So density is known. Okay. So why don't you work that out? Alright, so let's work this out. I have number of moles is given 0.200. That's my N moles of ethanol. Okay, C2H5OH. I changed that to mass in grams, right? Using the molar mass, which is 46.07 grams per mole. So times 46.07 grams in 1 mole of ethanol. Okay, C2H5OH. If I did that calculation, I'll get my mass in grams, which at this point would be what? 46.07 times 0.2, which is 9.214. Okay, 9.214 grams. And then what do I do to change that to mils? Density. So volume is what? Mass over density, right? Okay. So volume is mass over density, or you can use your dimensional analysis. You have your mass, so your density goes down here, which is going to be 0.785 grams per mil. So 1 mil goes up here. Okay. Grams cancel out. So 9.214 divided by 0.785 gives me 11.7 milliliters. Very good. So you got it right?